Hi viewers, welcome. We deal with the subject Engineering Mechanics, Introduction to Engineering Mechanics. Engineering Mechanics is a very interesting subject which will be covered in all the branches of first year of your engineering. Engineering Mechanics is nothing but the branch of applied science which deals with the laws and principles of mechanics along with their application to engineering problems. Nothing but simply we can say nothing but an applied science that describes and predicts the effect of forces on objects either at rest or in motion. Suppose consider a body, and have applied a force F. What is the effect produced by this particular force F on this particular body B? We will deal in engineering mechanics. The effect produced by this force on this body will be dealt in engineering mechanics. Before starting, we deal with the definition of the engineering mechanics. Engineering mechanics is nothing but the science that describes and predicts science that describes and predicts the effect of forces on objects either it's either at rest or in motion, or we can simply say either static or dynamic. Static means nothing but simply the body which is at rest is said to be static and the body which is in motion is said to be dynamic. Therefore, the engineering mechanics deals with the objects, the forces and their effects on the forces of the objects. What is the effect produced by the forces when it is acting on an object? We know that force is nothing but a vector quantity. Before that, what is meant by force? What is by effect produced by this force? We will deal in the engineering mechanics. Force is nothing but action of one body over the another body. Action of one body over the other. Action of one body over the other means here I am applying a force F. This F will be applied by using another body. That body will insert some force or exert some force on this particular body B. That exertion of force are nothing but the effect of or the action of one body effect on the other body is said to be a force. Force tends to move the body in the direction of its action. Nothing but if I have applied a force to this body, F is the applied force. Force is a vector quantity. Vector means it has both magnitude and direction. Suppose if I have applied a force F, then this body will tend to move in the direction of applied force. It means the body will move in this direction. That is said to be a force. Nothing but the action of one body over the other is said to be a force. That is why it is termed as a vector because it has both magnitude and direction. Here it indicates the direction. Magnitude is nothing but the quantity is said to be magnitude. Suppose F equal to 5 newtons in the direction, in which direction? In the east direction. This 5 newtons is said to be magnitude and this east is said to be the direction. So force is said to be a vector quantity which has both magnitude and direction and effect of one body over the other. In engineering mechanics, we deal with this effect produced by this body which is coming into the force or which is giving the effort to the another body. That effort, what is the behavior after acting this force on that particular body, we will discuss in that. Before that, starting, this is the introduction, engineering mechanics. Okay. Next, coming to the divisions of engineering mechanics. The knowledge of this subject is very essential in designing of all types of structures and machines. So this is one of the core subjects to the structural design or the civil engineering or mechanical subjects. So divisions of engineering mechanics. The engineering mechanics is mainly divided into two groups. First one is the statics and second one is the dynamics. They're mainly the division of engineering mechanics. Engineering mechanics is divided mainly into two main groups. That is, one of them is static and another is dynamics. Static is the branch of engineering mechanics which deals with the forces and effects while acting upon the bodies at rest. In the starting, we have discussed statics. Static means the bodies which are at rest, and the dynamics means the bodies which are in motion. Suppose F is a force which is acting on a body F. If this F is acting on a body which is at rest, then it is said to be static. Nothing but the force and their effects while acting upon the bodies at rest. This force is acting upon this particular body B which is at rest, then it's said to be statics. Next, dynamics. Dynamics means deals with the forces and effects while acting upon the bodies in motion. If the same force acts on another body which is in motion, then it is said to be dynamic. The force which is acting on the body B, any body, the force which is acting on the body B which is in motion is said to be dynamics, and the force which is acting on the body which is at rest is said to be statics. The dynamics, again, it is mainly divided into two branches. The dynamics is mainly divided into two branches. One is kinetics. One of the branch is kinetics and the other is kinematics. Kinetics is nothing but the branch of dynamics. So it is a branch of dynamics that deals with the bodies in motion due to the application of forces. Whatever the forces acting on this particular body, we will deal with that particular forces. Nothing but the relationship between the forces and resulting motion on an object. Suppose consider the body. If F is a force which is acting on the body, by this force, what is the distance moved? What is the changes produced in this particular body? The relationship between the forces and the resulting motion produced by this force on this object will be dealt in kinetics. Nothing but the relationship between the forces. Relationship between the forces and the resulting motion on the object And next, coming to the topic called kinematics. It is another branch of dynamics. It deals with the study of motion of bodies without any reference to the forces causing the motion. Suppose consider a body acting the force F. What is the effect produced by this body only considered, but this force is not considered. That means if this particular force produced that some motion in the body, only that motion is considered, but not this force is taken into account. The force is not considered means nothing but the without any reference to the forces causing the motion, without any reference to the forces causing the motion. That means only the forces causing the motion. Nothing but only the motion of the body is taken into consideration, but this force is not taken into consideration. This is the divisions of engineering mechanics. One is statics, that means which is at rest, and dynamics, which is in motion, and is again divided into two topics, kinetics and kinematics. This is the relationship between the forces and the resulting motion on the object. It is the force that which is not taken into account, but only it deals with the forces which are causing the motion. And next, we deal in detail about the force, which were already discussed. Effect of one body over the other body is said to be a force. For example, to pull a cart, horse will apply some force. That is, this effect produced by the horse in this cart will make the cart in motion. It means whatever the goods present in the cart will be shifted or will be kept in motion by this horse. That is nothing but a force is coming into an action. That force is exerted by this particular horse on this cart. That is why this cart is having in motion. We cannot say that applied force F must produce some motion. For example, I want to lift a stone which is of Suppose say 1 ton. So if I want to lift this 1 ton stone, I cannot sustain this. Means the force is not enough to sustain this load. Means to lift this load, the force is not enough. Suppose I want to keep this body in motion. This force F need not to produce the body in motion, but it tends. Tense means impending, means tends to move, means not in motion, means about to move. This force need not to make the body in motion. Only this F force, when it is enough to move the body, then only the body will be in motion by this applied force F. We will deal about the effect of a force. What are the different effects of a force? The effects are, suppose a body is at rest. To keep it in motion, I can apply a force F. By this effect of this force, the body will be in motion. Suppose I want to already the body is in motion. I can increase the motion by I am applying force, another force F. Nothing but F is used to accelerate the body. I am repeating once again. F is used to accelerate the body. In the first case, I am applying the force F on the body which is at rest. This force F will tends to move the body. Here the body which is already in motion, I am applying force F. This force F will accelerate the body. Suppose if the force I am applying opposite to the motion, if suppose this force is F1 and applying another force F2, okay, opposite to this direction, that means if F2 is greater than F1 or F2 is equal to F1 or F2 is less than F1, whatever may be the condition. Suppose if F1 equal to F2, that is the body is said to be in equilibrium. Means whatever the forces acting on the body in this direction are equal in this direction, then the body will be in motion. Suppose I want to push a stone with an applied force F1, another friend is pulling this body with an applied force F2. If F1 is equal to F2, then the body will be at rest. That means nothing but the body is static. The body is said to be static. If this F1 force means, considering this case, if F1 force is less than F2, the motion of the body will be in this direction. If applied force F2 is greater than F1, that means simply we can say F2 is greater than F1. Suppose this is F2 is less than F1. When F2 is less than F1, the body will be moving in this direction. This is the cases which we are nothing but the effects produced by this particular force. It means nothing but the force retards the motion. Means retards the motion and also accelerates the motion and keep the body in equilibrium. By applying some force on a particular body, the size and shape of the body also changes. That is the effects produced by this particular force. Nothing but the effect of one body over the other. It need not to keep the body in motion, but it tends to move. That means the about to move. Okay, the force whenever it is necessary, means the force required to move the body. If its force is enough to move the body, then only the body will be in motion. Force not only makes the body in motion, it also decelerates the motion. Nothing but retards the motion, accelerates the motion, keep the body in equilibrium and changes the size and shape of the body. Now next about the characteristics of a force. The characteristics. What is the necessity of characteristics? To know the effects of the body, we should know the characteristics of the forces. In order to determine the effects of force acting on a body, we must know the following characteristics of a force. The first and most is the magnitude. What is meant by magnitude? Suppose 10 newtons. This 10 newtons is said to be magnitude. 20 kilonewtons is said to be a magnitude. 30 newtons, 50 kilonewtons. These are said to be magnitude. This magnitude is necessary to determine the effect of the force. And next is the direction. In which direction you are applying? Suppose I am applying the force in the direction of, from, suppose consider this is from west and moving from west to east. This direction, this indicates the direction of line with some angle of inclination. And the third, which is the nature of the force, nothing but either push or pull, either push or pull. Suppose consider a body, this is said to be the push, and same force this will be replaced at this point is said to be pull, that is said to be push or pull. And next with the point of application, where we are applying this particular force. Suppose consider a body B having points A and C. This point of application is also comes into account to deal with the effects of the forces. These are the characteristics of the forces. The first is the magnitude. What is the magnitude? Suppose the force applied is of 10 newtons is said to be a magnitude. And next coming to the direction. These both makes the force to constitute as a vector. Under the action of these two, means that under the conditions of these two, the body is said to be a vector. The first, to meet the effects of forces, magnitude is required, and next the direction is required, and next the applied force. It means nothing but it is a push or pull. And where we are applying the force, nothing but the point of application of the forces.